So our two options. If I'm thinking, yeah, since y'all are normally more big on the plug and chug stuff, I think the analytical stuff might be harder, quote unquote, for you. But that doesn't necessarily. Yeah, yeah. So we can either do problems where the angle is actually increased. So instead of rolling off of the table flat out, it's shot at an angle. So like, because then we have to take into account the horizontal and the vertical velocity, or we can do some more analytical type problems that don't involve angles. It's just rolling off the table. So which would y'all rather do? More analytical? Okay. Reasonable. Yeah. I could plug and chug all day long, but you give me an analytical problem. Okay. Yeah, and there were no numbers there. And sometimes the scary thing is that you can get an answer that is relational instead of like actually well, it is correct though. It's a relational answer. It's not like a numerical answer. I wouldn't say that it's any less correct though. So since we're not really doing quizzes, because normally I would have like these little mini quizzes and we would take them every time. I'll give y'all a question from one of my quizzes that I wrote, and we're gonna go. I'm gonna go ahead and draw the picture out for us. You got an object that is on a ramp. We'll just say that it's a ball, and it's on this tabletop. So when it goes down the ramp, it's going to leave with a certain velocity, and then it's going to make this trajectory down towards the bottom. Friction does not exist in this case. The distance that it goes from the tabletop to the ground, we're going to call x, and the distance from the table to the floor, we're going to call h. And so we've got velocity, we've got h, and we've got x. And this ball is rolled down a ramp so that it leaves the edge of the table with this velocity v. Okay, it could be anything, but it is a velocity v. If the table has a height h above the ground, how far away from the edge of the table, a distance x, does the ball land? And we can neglect every single form of friction known to mankind. This is you would actually have to write it out all the way. So what we're looking for is ultimately we're going to be looking for x equals something. And like we need to figure out what that is equal to. So the way that we're going to do that is we're going to write out our DVATs. Everything that is not specifically mentioned here, we can assume that we do not have. So if it says that it's got a v, we can assume that we have that velocity to work with. Okay? So let's go ahead. All right, you want to devat it? So we got our x, we got our y direction, and we're going to make a devat. Do we have the dy? Do we have the dx? Yeah, it's x. Do we have the? I know, like our immediate thought is to say no, but it's actually given to us in the problem. It's what we're solving for. So we're going to want this to be in the equation. Do we have the? Uh, do we have what's a dvat? Dvat. Do we have the initial velocity? It's v, right? Do we have the final velocity? It should also be v. If it's going, because remember this is the x direction, right? So it's moving at a constant speed in the x direction as it goes through. Does it have an acceleration? This one is 0, so we actually know that one. Do we have the time? Okay, so we don't. It doesn't say time t, right? So we don't know how long it takes to actually hit the bottom. We can find an expression for time t, but it's going to not be a number. It's going to be a variable. It's going to be an expression. Right. dy. Do we have dy? That's our height, h, right? Okay. Do we have viy? What is it? 0. Do we have VFY? What is it? I don't know. Not 0. Remember, yes, it does hit the ground, but we're looking for the point right before it hits the ground. So we're taking a snapshot here and then right before it hits the ground. Or else you're going to get 0 equals 0 for everything, which is not wrong, but not useful at the same time. Okay, the acceleration in the y direction? Negative 9. Oh, wait. Sorry, yeah, let's do g. My poor computer. Yeah, it's trying to record and do everything, and this thing is like the oldest computer in the school, so g. I'm just going to call it g. And if it's going down, it'll be negative g. And then the time, we don't know. Okay, so we're trying to get everything in terms of v and h. So, all right, where would we want to go from here? We're trying to find the horizontal distance that it traveled, which means we do need the time. So the time's got to be an expression because velocity is distance over time. So we're going to have to solve for the time. It means we need to look at the y direction first. We have equations. Vf squared equals Vi squared plus 2AD. Vf equals Vi plus AT. I think I'm writing them in the wrong order, but that's okay. Displacement equals VIT plus 1/2 AT squared. And then there's the forbidden one, which is obscured in a cloud of smoke that we can't see right now. Oh, forbidden equation. Okay, I'll write it in. D equals VI plus VF over 2 times time. Every time you mention the forbidden equation, your eye is just going to hurt more, is what's going to happen. It's a curse. The forbidden equation is cursed. VI plus VF over 2. It's cursed because it's not on the AP Physics formula sheet. That's the only reason that I have. That's the only justifiable reasoning that I have here. Which one do we want to pick? First one, VF squared? Uh, right, uh, but we can, um, let's see here. The distance in the VF squared is the height, right? So we do probably need to include the height inside the problem. So the first one actually does look tempting to use. Um, we can go with that. There are two different ways to solve this problem, and actually there's probably more than two. But let's try it. Let's do the VF squared equals VI squared plus 2AD. So VF, ooh, that's in red. That's okay. VF squared equals VI squared plus 2AD. Now what I'm going to do is I'm going to substitute in everything that I know in the problem with letters. So like for example, the D, since this is in the Y direction, this is going to be H. So this is going to become uh, VF squared, oh, is it really just 0? VF squared equals 0 plus 2GH. So our final velocity at the end is going to be equal to the square root of 2GH in the y direction, right? That is an expression that tells you, and here's the cool thing though, is that we know gravity and we know the height of the table, so therefore the square root of 2GH is basically the formula for the final velocity of something that is falling. And in fact, you're going to be, y'all just kind of accidentally stumbled upon one of the frequently used expressions in AP Physics, which is the square root of 2GH. It comes up a lot, and this happens. This is not a win moment because you did not successfully find the horizontal distance, nor did you find the time because you did not select the formula that had the time. So, the so this is a yeah, and I get it. And the reasoning is that you have two different variables, but let me try to put it this way. The fact that you have two different variables means that this is an opportunity for substitution. And if you have two, because you can solve for two variables if you have two equations for two unknowns. So that's what we're going to have to do. Now, go ahead and keep in mind that VF equals the square root of 2GH. That's useful, but that's not what we were looking for. So did it work? Yeah, physics always works, but we just picked the wrong equation. Let's try this since this one has distance in it and not VF. Well, actually there's a couple of different things we could do now. How complicated do y'all want to make this? Not complicated. Okay. So, not complicated is we want to try to solve for the third equation. And the reason we want to use the third equation is because I know that this distance is h, and I know that this acceleration is g, and I know that this is 0. So the only thing that matters here is I'm going to get a relationship between g, h, and time, which is going to be really nice. So that's going to be useful to us. So I'm going to try to solve using the third equation. If I solve for the second equation using VF being the square root of 2GH like we just did, we will get the exact same answer. But I don't want to do the same thing twice. So let's keep it simple, and we'll just pick the third equation and do it that way. So our displacement, so D equals VIT plus 1 half AT squared. I'm going to rewrite everything that I know. So this is H. This is 0. That's gone. So 1 half GT squared. So I want to try to solve for the time. Okay, so I'm going to multiply both sides by 2, get 2h over g equals t squared, right? So I multiplied by 2, I divided both sides by g, and I got t squared equals 2h over g, and then take the square root of both sides. So the square root of 2h over g is equal to t. Are we in agreement there? We did do something similar to this yesterday. Yes. Yes. Fair, fair. That's totally fair. And now for t, I'm going to erase this question mark, and I'm going to put in the square root of 2h over g. Square root 2h over g. Okay? If I want to find the horizontal distance, I now have everything over here that I can use because I know that my velocity is equal to distance, which is x, over time, which is the square root of 2h over g, right? Now, we know the initial velocity, so that's doable. Since it said that it left with an initial velocity of vi, and we know that that was in the x direction, this actually works. So if I want to solve for the x direction, knowing the range, knowing the horizontal velocity, and not knowing the time, here's what we'll do. We'll just solve for x. So we'll just take this entire square root and we'll just move it to the other side by cross multiplying. So our velocity, yeah, our velocity times the square root of 2h over g is equal to the x displacement. So the answer to that question on the quiz was v times the square root of 2h over g is equal to x. So whenever I say x is equal to something, this little expression right here is what I'm looking for. Okay? Which doesn't mean that it's all or nothing. Like whenever I grade quizzes, if you have, like for example, I'll give you points for the DVAT. So like say this was a 5-point problem. You draw a picture, you draw DVAT or something that shows that you're setting up the problem, that gives you points. Did you use the right kinematic equation? That's the next point. Did you properly do substitution? That's the fourth point. Did you get the answer correct at the end? That's the fifth point. So you can mess up, because I know a lot of people mess up in the algebra in places. You can mess up in the algebra, and as long as you like picked the right equation, did the DVAT, like as long as you thought this problem through, you're doing the proper physics, you can easily get 4 out of the 5 points for a problem doing this. And the AP Physics open responses, they do that too. Like the worst thing you can do on an open response problem is don't do it. Yeah. And there are several different schools around us that whenever they get their AP scores back, they're all ones. So like nobody gets a 2, 3, 4, or 5, and it's because whenever they look at their open responses, they saw the question and just like immediately gave up. So normally if you just like start even setting up the problem and using the basic physics, you get points out of it. So and I do the same thing too. So whenever I give quizzes and stuff like that, I try my best to, because if I grade you like the AP Physics stuff, then you get a general idea of what they expect. Yeah, because a lot of people think that they expect like absolute perfection, and they don't. They actually grade it very fluidly. As long as you're doing the right physics, you can. There are plenty of opportunities to mess up and get lots of partial credit out of it. You have to Yeah, yeah, basically. Yeah, exactly. Exactly, and even then, it's still a very difficult test. Um, okay, so I think that's a good one. I had that one for my quiz. I don't think I have a different one. Yeah, this question was on a quiz that I used before. It will not be on the quiz that we use, or if it is, it's because I copy pasted it. I do need to give you guys a test on this stuff. The homework is what I've been using instead of the quizzes this year, but I do need to give y'all a test, and I probably need to like let. No, I know how to make the test. It's already made. But I need to really ask you guys what day you want to do that. Like next week, what day? And don't say Monday or Tuesday, because I still have we still need time to practice. So you just yeah, right. If you hey, we can do it Wednesday, and I can set up the test digitally. I can totally do that. Okay. Thursday. I mean that's reasonable to me. And then during the digital day, you can just ask me questions. Like just if you need to ask me questions during the day, I'll totally be there for you. Um, Basically, Wednesday will be review for the test. Yeah. And I mean that seems reasonable for a digital day because I'll be here. You just have to ask me a question. I'll totally respond. I don't know yet. Okay. Let's try it. I don't know. Do y'all want to try another one of these or we'll survive somehow. It'll probably be some kind of exercise on G code, but I want to stay on physics right now. Do y'all want to do another analytical one or do you want to do the angle one? In terms of analytical solutions, I don't think they will give you an analytical problem that deals with angles because that starts getting real complicated real quick. So if they do, it'll be straight up and down. So we haven't done a straight up and down one yet, but you're gonna find that it's gonna be real similar. So let me give y'all a straight up and down example, and I think you'll find out that you'll be like, oh, okay, so it's really very similar. Let's take an object and let's throw it up in the air. So, like, you are practicing your archery and you're also really dumb at the same time. Not to say that you're dumb, this is just like a hypothetical situation. You take an archery and you just shoot it straight up in the air, which most people would tell you, please don't actually take yeah, please don't actually take a bow and arrow and shoot it straight up in the air because there is a very small chance that it will just come straight back down. And if you're going by the laws of physics and ignoring friction, it's going to fall straight back down. So this goes up a certain distance and then it goes back down. Okay? And let's say that we like what would be like the easiest things to measure with with this setup? If you're launching something into the air, what pieces of information of the DVAT can we easily measure? So let's think about this. You got, okay, yeah. So VI, VF, A, and T. So we know that the acceleration is g, and I'm only going to use letters now. I'm not going to use, so 9.8, otherwise known as little g, okay? Um, would it be easy to find the initial velocity? Let's say that we're trying to figure out how high the arrow went. So we're going from this position for our initial to this position for our final. So we're going from here to here. So initial would not be 0. You are shooting the arrow. So we are focusing on whenever you just release the arrow. When you just release the arrow, it has a speed. When it reaches the top, VI is the speed? Okay, so we don't know it, right? Okay, what's the VF? 0? Okay. Um, and what about the displacement? Let's call that H. That's what we're trying to solve for. Okay. So let's run through a couple of situations and let's see if we can solve for the time and what we would actually need to be able to get a formula answer for this question. Okay, so like for example, let's go ahead and run out our VF equals VI plus AT. VF squared equals VI squared plus 2AD. And then there's displacement equals VIT plus 1/2 AT squared. Our three equations. I'll make that a little cleaner. VIT. The forbidden equation. Do y'all really want to do that? I mean, like, displacement equals VF plus VI over 2. I guess the more times I put it up there, the more likely you guys are to remember it. Okay. Fair. So there are a couple of different things that we can do. So if I want to try to find out how high it went, um, there are several different ways to do this. Um, if I look at the first equation and I solve it for t, that means that first of all, the VF and the VI have to go over to the same side first, AT, and then if I solve for t, it would be VF minus VI over A. So this doesn't have anything to do with the height, correct? Okay, so this wouldn't really help us. There's no height in there whatsoever. Uh, next one, if I were to look at VF squared equals VI squared plus 2AD, is there a time here? Or sorry, there is a D, but there's no time. So let's try that. If we do VF squared equals VI squared plus 2GH, which notice I just took the A and made it G, and I just took the D and I just made it H, because this kind of applies to the problem that we've got here. And I want to solve for how high it goes. That means that I would need, this is 0. So that means that we want to solve for the height, right? So let's take the VI, let's move it over. That gives us 2GH. And to get H by itself, yep, so it's going to be negative VI squared over 2G, and that would give us the height. So what we would need in order to solve this problem is doing it this way. I would need the initial velocity squared, which if we just find the initial velocity, it's easy to square that, and that's it. If I had the initial velocity, I could find the height doing this, and that's it. So that's not too terribly bad, but the variable that I would need there is I would need the initial velocity. Okay, so if we could solve for the initial velocity over here, that could actually be useful for us. Wasn't the final velocity 0? So I could kind of tweak this a little bit, and I could say this is really negative vi over g is equal to t, right? And if I were solving for negative vi, wouldn't that be equal to gt, gravity times time? Oops, I said gravity times time, and then I squared it randomly. Okay, just random squaring, no big deal. Everything's fine. You add an extra a at the end of a sentence, nobody cares. Add a squared at the end of an expression, people go crazy. Uh, but I have a vi squared over there. So if I wanted to solve this in terms of time, I could substitute that in, and I could get an expression just using gravity and time instead of the initial velocity, which makes a whole lot more sense to me, because if I'm pulling a bow back and I'm letting it go, what are my chances of actually getting an accurate measure of the initial velocity of the arrow? How are you going to do that with a speedometer? A speedometer is attached to a car. How are you going to do that with an arrow? I mean, like you could use a rangefinder, but an arrow's really small, right? It's not big, and we already have trouble with things the size of carts. An arrow is much, much thinner. So it makes a lot more sense to be able to just take a stopwatch and time how long it takes to go through the entire flight and then divide it by 2, and that would give you your time. Okay? Because whenever it goes up, what goes up must come down. So you just measure the entire time length and then cut it in half, and there's your time. In this case, it doesn't really matter because we can call the time t. So I'm going to do that. I'm going to take this. Time is always going to be t. Well, yeah, I every time I do the variable time, I'm going to use the letter t. Yeah, I mean that's true. Um, so I'm going to take this and I'm going to put it over here. I'm going to make the negative go to the other side and just say that the velocity is equal to the negative gt. Since there's a squared here, this will get the whole positive and negative is going to get pretty hairy pretty quick, because technically g is negative 9.8 meters per second squared, so it's always pointing down. But if I have a negative g is at a negative 9.8 meters per second, I'm just going to look at once the I'll because it's going to get squared anyway. I'm going to just look at the problem and then sort it out whenever we get there. So I'm going to move this over here, and I'm going to say that this is negative gt squared over 2g is equal to h. That's the same thing as vi squared, right? So can we simplify that? Yeah, we can. These are letters, right? So using our rules of algebra, um, if I square a negative number, it becomes a, okay, so I still have this negative out front. So that's going to be g squared, t squared over 2g equals h. Can I do anything else? Okay, I can get rid of these, right? Bye-bye. Everybody brought g to the party. Bye-bye. So that's going to be our height is going to be equal to negative gt squared over 2, right? And that is a formula that makes a lot more sense to us than having the vi squared over 2 in a realistic sense, because we can just use the stopwatch to get our value. And we got that answer using um, a stopwatch. Okay. I thought this would be similar for you guys, but it ended up not being that similar. If we wanted to find the final velocity, we would get the square root of 2gh. Um, and all that fun stuff. Now, the negative makes sense to me because we assume that g is negative 9.8, so that would be negative 9.8 squared, which means that you would actually get a, yeah, you would actually get a different number for it. Okay, does that make sense? Okay, cool. So that would be like a formula for how to find the height. That would be another example of an analytical solution, is using substitution in the kinematic equations to get us something that we want. Okay? Normally they're not that difficult. I just was making something up off the top of my head though. I don't know. I prefer to use the term just like I'm just going. I don't really know. I don't like gauge the difficulty instantly and be like, yes, yes. I can't really predict where it's going. I'm not that smart. I'm it's just, hey, let's figure this out and let's see what happens. Um, and if it just happens to be that something that requires a little bit more flexing, then we'll just have to flex a little bit harder. Okay? So, does this answer make sense? We do get a squared, right? So that does indicate that you have a parabola to go along with it. So that makes a lot of sense as well too, because your displacement should go up, and then once you reach a certain distance, it should go back down as time goes on. So yeah, that does make sense. It really just kind of depends on where the parabola is. So, um, any questions on that one? No comments, concerns? Sure, I'm ready. You said you. Oh, I thought you said you have questions. You're like, I have questions. I'm like, let's go, shoot. No, not necessarily. All right. If we do this at an angle, though, so if we actually launch this and the launch point is not at an angle, and this is going to be a little bit more plug and chuggy. This isn't going to be analytical because I rarely see analytical stuff done in this fashion, but I can always be proved wrong. So it's worth at least going over so that you guys can actually put two and two together. Let's say you take like a cannon and you launch a ball or projectile or whatever makes you happy out of the cannon. And it makes this trajectory as it goes through. There are a couple of things that we have to take into consideration for this entire trajectory. When we do our DVAT, it will make a pretty big difference. So I'll go ahead and I'll make up some numbers for it. Let's say that we shoot this thing off at 60 meters per second. And let's also assume that the angle that we're shooting it at is 35 degrees. And honestly, I think that's all we need. So, can we find from just the speed of the projectile, can we find the height of the maximum height of the trajectory? Can we find the range, which I'm just going to call x, the horizontal distance? We can call it d too, but I'm going to use x for the horizontal distance. And can we find the time? So I'm looking for three things here. I'm looking for t, I'm looking for h, and I'm looking for x. And I do have two things. So I have a speed and I have an angle, and a couple of other things that can be used as well too. Um, can we find all of these pieces of information using our tools of kinematic equations? And the answer is I think so. Uh, we'll find out. What do we do? Okay, so if you're saying g in the y direction is negative 9.8, the acceleration there, the first thing I need to do is I'm going to go ahead and split this up into two categories. There's going to be the x direction, there's going to be the y direction, and I'm going to write my DVATs out for it because this gets complicated. I would recommend you always use your DVAT for stuff like this because you're going to get variables all over the place. So I'm going to do dy, vi y, vfy, ay, t doesn't have a direction. So dvat, and we know that this one is negative 9.8. We'll use numbers this time to make y'all happy. Negative 9.8 meters per second squared. Do we know anything else about the Do we know the y? Do we know the height? Okay. So can I go ahead and just call that h? Okay. So this is going to be like a semi-analytical answer, kind of like semi-sweet chocolate. I'll just use h for the dy. The initial y direction velocity? It's not 0 and it's not 60. It's neither. No. Is it neither. None of the above. We can find it. We can find it. We can find it right now. We can find it right now. Let me expound upon this vector over here. So like this is going to be our vector of 60 meters per second, and it has, as you guys know, a x direction, and it has a y direction that goes along with it. And the angle is 35 degrees, yeah. So we can use SOHCAHTOA, exactly. So, and there is a 90-degree angle. Yeah, there's this part right here between horizontal and vertical is always 90 degrees. So SOHCAHTOA applies. 60 cosine 35 is going to be the x direction. 60 cosine 35 is going to be the x direction. 60 sine 35 is going to be the y direction, because this is the opposite side. This is the opposite side of the angle, and this is the adjacent side of the angle. So if we do opposite over hypotenuse, that's going to be the sine. So that means it's going to be 60 times the sine of 35 degrees. The adjacent is the cosine. Um, you can also keep this in mind. Y sine, x cosine. That as long as you're like using the angle to the floor, that's always going to be true. The y direction is the sine, and the x direction is the cosine. That's always going to be true. So you don't even really have to do SOHCAHTOA. So this guy over here, this is going to be 60 sine 35, and this one over here is going to be 60 cosine 35. We just need numbers for that. Yeah, please put your calculators in degree mode, because this is 60 cosine 35 degrees. Most of the time in AP Physics, we will be in degrees. There's very few circumstances where we use radians. For the most part, we are in degrees. What do we get? Which one are we looking for? Y? So I want the 60 sine 35. Okay, what is it? Do I get a second? Okay, 34.4 meters per second. Positive or negative? Positive. Okay, what is the VFY? VFY? Okay, so there are two different ways to do this. If you try to find the VFY all the way across, that is perfectly fine. Or you can cut this problem in half and you can make the VF 0, but at the end, you're going to have to double the time because it's going to take twice as long to make it across. Either way is acceptable. But, well, you can find the VFY like either way right now. Okay, the VFY is negative 34.4 meters per second. Because if it's going 60 meters per second this way to start with, by the time that it reaches the bottom side of the arc over here, it's going to be moving 60 meters per second on the other side, because the energy that it lost going up here was then it was then gained going back down here. So if you've got 60 meters per second at 35 degrees going this way, once you reach 35 degrees again, your y direction is going to be the same speed yet opposite number. So our VFY is going to be negative 34.4 meters per second, or we can say we're only interested in trying to find the height, so therefore the VFY would be 0. It is up to y'all. What do y'all want to do? How many of y'all want to do 0? How many of y'all want to do negative 34.4? Okay, we're going to do it that way then. All right, so the VFY is negative 34.4 meters per second. Okay? I I forget as well, so I don't blame you, to be honest. The x direction, dvat. So dx, vix, vfx, sorry. Acceleration in the x direction, and time has no direction. Okay. Dx is the horizontal distance x. Do we have a initial x direction velocity? 60? Can't be 60. 60 is the total speed at 35 degrees. I need this. Because if I add both the horizontal speed and the vertical speed together with the Pythagorean theorem, I should get 60 meters per second. But 60 plus something else will never be 60. What is it? 49.15? Let's do 49.2. Do I get a second? About right. Y'all making me nervous. 49 point. Okay, you want to do one or two? 49.1? Okay. 49.1 meters per second. All right. The VF? No, ma'am. No, ma'am. Think about what's happening in the x direction. Think about think about what's happening in the x direction. Is this thing moving? Yeah, this thing is constantly moving at a consistent horizontal velocity all the way across. So as we continue to go across, the horizontal velocity does not change. So that is still 49.1 meters per second. Okay, what's the acceleration? 0 meters per second. Because it's not speeding up or slowing down. Squared. 0 meters per second squared. I had to add the squared in there real quick. Time, we don't know. It's just t. I don't know. So time for the kinematic equations. Let's see what we can do. On the left side, it's just distance over time. Can we do anything with that so far? We don't know distance and we don't know time, so it looks like trying to find time is going to be important to us. All right, VF squared equals VI squared plus 2AD. VF equals VI plus AT. Displacement equals VIT. That looks like an N, sorry. VIT plus 1 half AT squared. 1 half AT squared. And then displacement equals VI. This one might be useful this time. VF divided by 2 times time. The forbidden equation might be helpful. Okay. Not today. It could be. All right. Which one y'all want to pick? Forbidden equation? I thought you said it wasn't good. I don't care. Yeah, do you want to find height first or time first? I do not care. Height first? So then that means first one, VF squared equals VI squared plus 2AD. You have VF, you have VI, you have A. Seems reasonable to me. Yeah, let's do that. So we'll use the second equation, happy times, and then we're going to say VF squared, it's the same number, it's just opposite, right? But when you square it, don't forget that negative goes away. So it's 34.4 squared equals 34.4 squared plus 2 9.8 times d. What do you mean? You say that the displacement is equal to 0? And I'm going to say, of course it does. Of course it does. Why would it equal 0? Didn't, yeah, because you went up and then down, right? So if you so if you're gonna do it, yeah, so like if you're gonna find the height, if you want to find the height of the object, because you're trying to find h, right? If you want to find the height of the object, then this needs to be the VF needs to be 0. Okay, so what we're gonna do is we're gonna do the same thing. Let's just take that 34.4 and let's just make it 0, and that'll make us find the height. So I'm gonna say that my VF is 0. What do I mean it's 0? You talking about this one? Or are you talking about this one? You're okay? Not mentally traumatized? Not yet? Okay, okay. So if you make the VF 0, that'll give you the height because that's whenever the vertical velocity stops. Okay? Sometimes we just have to make those mistakes before we really appreciate why we do what we do. So take away 34.4 squared, divide by, oh no, it's time to go. I guess we'll pick up on this later. Have fun, I'll see you Monday. The good thing about this is it's digital, I don't have to erase it. Have fun.